Today you're going to be looking at putting more than one relationship on a graph. In this case, it is called Love at First Jump. So Mr. and Mrs. Mulock got married while skydiving. Mr. Mulock was running a little behind schedule and missed their plane. He caught the next one. Although both Mr. and Mrs. jumped at the same time, Mrs. jumped from a plane at an altitude of 3,500 meters, but Mr. jumped at an altitude of 2,600 meters. Two possible ways to skydive, or two positions, would be, first of all, the spread stable position, where your body is sort of out, so it has more air resistance, and the speed at which you fall is lower, or the diving or standing position, in which your body is more streamlined in a line, which has less air resistance and you dive at a faster rate. Now, because Mrs. jumped from a plane at a higher altitude than Mrs. Mulock needs to be in a diving or standing position. Mr. Mulock jumps at an altitude of 2,600, so he is going to use the spread stable because he went at a lower altitude, so he needs to wait for her to catch up. So he needs to slow down his descent, and she needs to speed up her descent. All right. You don't really need to know about the, it's not that important to know what kind of skydiving position you're in, but it just lets you know who's what. So for Mr. Mulock, he is falling at a speed of 50 meters per second. Now remember, speed is similar to rate of change, but speed doesn't take the direction into account. So the rate of change here, which we call the m, is actually negative 50. So remember, speed is not exactly rate of change. Speed is just the positive number. It doesn't take the negative into consideration. So because they are decreasing their altitude, his rate of change is negative 50. And since he jumped at 2,600, his initial value, which we call B, is 2,600. Now for Mrs. Mulock, she's going to fall at this speed. So the speed is positive, and because her altitude is decreasing, the rate of change, which we call m, is actually negative 80, and she starts at 3,500, so her initial value is 3,500. Now, to make an equation for each of them, A is representing the altitude, T is representing the time in seconds. What we probably should have written here is the altitude in meters, because your let statements should have the variable and the units. And something else to remember, when you make the equation, it's y equals mx plus b. When you make the equation, y and x should be letters, and m and b should be numbers. So Mr. Mulock's equation is, you start with the dependent variable, which is the altitude, equals the rate of change, which is negative 50, times the independent variable, which is t, and then plus the initial value, which is 2,600. For Mrs. Mulock, the equation is the dependent variable, which is altitude, equals the rate of change, which is negative 80, times the independent variable, which is t, plus the initial value, which is 3,500. Now we will make a table of values for each. So for Mr. Mulock, at the beginning, he starts at an altitude of 2,600. And after 1 second, remember the equation is negative 50t plus 2,600. So at 1 second, it's negative 50 times 1 plus 2,600. So after 1 second, he's at a height of 2,550. And at 2 seconds, it's negative 50 times 2 plus 2,600. So that would be 2,500. After 3 seconds, it's negative 50 times 3 plus 2,600, which is, I got too many zeros there, which is 2,450. And at 4 seconds, his height would be 2,400. So to calculate the first differences, you want to remember that you have to take the second one and subtract the first one. So it's 2,550 minus 2,600, which is negative 50. And then the third one minus the second one, 2,500 minus 2,550, that's equal to negative 50. The next one is 2,450 minus 2,500, which is negative 50. And then 2,400 minus 2,450. So all the first differences are the same. So this is a linear graph. Now, for Mrs. Mulock, at time 0, she starts at 3,500. After 1 second, so it's negative 80 times 1 plus 3,500, which is 3,420. After 2 seconds, which would be 3,340. After 3 seconds, oops, this is 3,500. So that would be 3,260. And after 4 seconds, that would be 3,180. And to calculate the first differences, 3,420 minus 3,500 is negative 80. 3,340 minus 3,420 is negative 80. The next one is 3,260 minus 3,340, which is negative 80. And the last one is 3,180 minus 3,260, which is negative 80. These are all the same, so this one is also linear. All right. So I'll tell you why that helps in a minute. Now we're going to make a graph. So on the x-axis is going to be the time. So we're going to put time here in seconds. And on the y-axis is going to be altitude. And that's going to be in meters. Now, here's where knowing that it's linear comes in handy. It's a little bit hard to plot some of these points. Maybe not so much ones that go up by 50s, but definitely ones like trying to figure out exactly where 3260 is on here, or trying to figure out where 3180 is on here might be a little bit challenging. So what you can do is you don't have to plot every single point. So we know at 0 it's going to be about 2600, which is here. And at 4 seconds it's going to be 2400. So looking at the scale, now there's a reason why it's a big scale. So we know at 4 seconds that's going to be right here. And that's going to be at 2400, like that. So you don't need to plot all of the points in between because we know they're all going to be on a straight line anyway. So when you graph this, it's going to look something like that. And we're going to label this as Mr. Mulock. Now for Mrs. Mulock, she's going to start at 3500, which is here. And at 4 seconds, she's going to be at 3180. And 3180 would probably be about here approximately. So we don't need to plot all of the points in between because it would be pretty challenging to do so. But that's the whole advantage of knowing that it's linear, because since they're all going to be on the straight line anyway, then you only really need to draw 2 points. So that is going to look something like this. And we'll label that as Mrs. Mulock. All right, now here's where the excitement comes in. Oh, we forgot one thing extra, which is the title. So this is going to be altitude versus time. All right, now the whole point of what this lesson is now going to get at is what are the coordinates of the point of intersection? So how does that relate, or how does that relate to this problem? So the point of intersection is, as it says, where the two lines intersect. So the two lines intersect right about there. And that's the point of intersection, which we often call POI for short, point of intersection. And it occurs at a time of 20 seconds and an altitude of about 1600. So the point of intersection we write as, so the point of intersection is about 20 seconds and 1600 meters. So that means 20 seconds, 1600 meters. And how that relates to the problem is that that is where they will meet up. That is when the time and the altitude are equal or the same. For both Mr. and Mrs. Mulock. So what that basically means is that it took 20 seconds for Mrs. Mulock to catch up to Mr. Mulock. So really, that's where they get married. So 20 seconds into their flight or their dive, that's when they catch up and they're able to get married. So basically before that, so before 20 seconds, Mrs. Mulock was at a higher altitude and Mr. Mulock was at a lower altitude. So what we're getting at are different cases where you're going to be plotting more than one relationship on a grid, and you're going to find the point of intersection, and you're going to be interpreting what the point of intersection means. And then you're going to be looking to the left sometimes of the point of intersection to determine who was higher or who was lower. And in some cases, if they, let's say that they decided they didn't want to get married and they just kept continuing, who would be higher and who would be lower. Another example might be if you were renting cars at two different places, you would be able to use the graph to determine when one car company would be cheaper than another car company. All right, so what you're going to be doing is looking at different scenarios, like I said, and graphing the two lines and finding the point of intersection. So everything we've done in previous lessons, except for actually figuring out what the point of intersection was. But we've done all of this already. We've found rates of change in initial values, we've made equations, we've made tables of values, we've calculated the first differences, we've made graphs. So the only new thing is just getting that point of intersection and then figuring out what it means.